Okay, so as we go forward today, our topic is still solving triangles, and the last 7 lessons we've been doing something called the sine rule, the cos rule, and the area rule. And so if you look at the basic formulation, this first one over here, this is the sine rule, and we can use it to find sides or angles. The second one over here is the cos rule. We can also use it to find sines or angles, but it depends on what information we're given as to which rule we will use. And then the last thing is the area rule, which allows us to find the area of any triangle as long as we've got 2 sides and an included angle. Okay, so let's start with a question from an old exam. And what I want to do is I want us to try and start by finding the length of CD. And in order to find the length of CD, I want a strategy. So let's start by that. In the chat, for those who have been around for a while, what strategy are you going to use to find the length of CD? So is there a tool, or is there something that we need to be aware of as we try to start and get going? Who has some ideas? Or you can raise your hand. So we're given this information, we're given a triangle with lengths and angles, and we want to find this CD. And I see Pafano, and I see lots of people are saying we should use the sine rule. Now, when we use the sine rule, it has the format that we had above. Let me actually bring that back in here. Let's just bring this out. I'll put this right above. So we are going to use the sine rule, and we're going to use it to find the length of a side. Now, when I want to find the length of the side, I always start by writing the sine rule where the sides are on top. So that would be this part over here. And so the side I want to find is CD. And so I go CD over the sine of the angle opposite CD, which is going to be, what's opposite CD? It's 80, so the sine of 80. And then I will let you guys try and complete. What do you think is on the other side? And then once you've got those other 2 bits, what is the final answer for CD going to be? Now, if you're unsure, what I'd like is I'd love for you to raise your hand, and then we can talk about perhaps what is it going to go here and what's going to go here using the sine rule if my goal is to find the length CD. Okay, so if you're unsure as to what goes in the box, I want you to raise your hand. If you know what's going on, I want you to go ahead and find me the answer for CD. Okay. Awami, let me unmute you.
Hello.
Hi, Awami.
Hi, sir.
What do you want to discuss?
I'm new, sir, so I'm not sure what you guys are doing right now.
Okay. So what I'm going to suggest is that if you look at the sine rule here, you need these pairs of sides and angles. And so in this case, we are going to find the other side that is given to us, which is here, and that's going to be 52. And so this is going to be 52. And then we go, what is the sine of the angle opposite that? It's going to be the sine of 60. So that's something called the sine rule, Owami, and it allows us to solve for unknown sides in any triangle if we've got the right combination of information. So now what I'm going to do is I'm going to get the CD all by itself by moving the sine of 80 to the other side. And what we get here is going to be, well, we multiply both sides by the sine of 80, and we're going to get basically the sine of 80 times by 52 over the sine of 60. And if you type that into your calculator, you should get, in fact, let me grab this bit down here. You should be getting 59.13. So for those who are new to this whole process, that's called something called the sine rule. And basically, when we've got a side and an angle opposite each other, and then another angle, we can use it to help us find a length.
Thank you, sir.
Perfect. Now, I want us to move on to 6.2, and 6.2 says find AD. Now, AD is up here. And again, in the chat, for those who've been doing this topic for a while, what tool are we going to use? Now, we did work out that this one was 59.13, but now we're looking for up here. And I want to know, what tool are we going to use to find AD? Okay, so I see lots of people are saying the cos rule. And when we say the cos rule and we're finding sides, the formulation of the cos rule that we use is going to be this one. Now, this I would recommend for students who are very new. You need to look at my video on using the cos rule to find sides. But for those students who are comfortable, I want you to go ahead and try and do it. For those who are still very new to this, we start by writing out the side that we want to find, which in this case would be AD, and we write it a bit like Pythagoras. We go AD squared, and then we go, well, if we're going to use the cos rule, we need two sides and an included angle in a triangle. And the two sides that I see are 52 and 74. And so we're going to start by writing down 52 squared plus 74 squared. But now you'll see in my rule, it doesn't just have that first part, it also has minus 2 times 2 bits. And then it has another bit where it says cos of an angle. And the two sides, you can notice from the pattern, they're the same as the ones that come up earlier. So 52 and 74. So that would be there. 52 and 74. And then the angle between those two sides is going to be 36. So that is writing out the cos rule in order to find sides. But the problem we have is I've written AD squared, and what I really want is AD. And so in order to get what that is, I'm going to have to square root both sides. So for students who are feeling comfortable with this, I want you to try and go ahead. For those who aren't comfortable yet, please raise your hand and ask a question. You should be seeing something like that happening. Okay, Imichle, let me unmute you. Hi, Imichle.
Hi.
Can you hear me?
Hi. Yes, sir.
What can
I have a question, sir.
Yes, go ahead.
I don't understand where the placement of the values A and B or B and C when you're substituting into the formula. Does it matter which values you use?
It does. It does. Okay. So what I want you to, and so this is where going to an earlier video will be helpful. But basically, when I was finding AD, in that triangle, I already have two sides, 74 and 52, and I have the angle between them. You'll notice that the two sides that I'm using are 74 and 52. So these ones are coming from my triangle over here. And they're the two sides that I know already in the triangle. And then can you see there's an angle in between them called 36? Now that is the cos of 36. That's where I get the angle from. And the side I'm trying to find is the side that's almost all by itself in this question.
Okay, sir.
Okay, but now what I would recommend is I did a whole hour on this, and I really would recommend looking, even if you watch 15 minutes of that video, it will help you a lot. Okay, last thing, we've got 44.2 is that length there. I want everyone to go ahead now. Well, I want to know in the chat, what tool, if I want to find the area of this whole thing, A, B, C, D, what tool am I going to use? Let me know in the chat. And then I also want to know, what strategy would you use, or what other information might we still need? So there's two questions. What tool would you use? And then what other information do I still need to find to use that tool? If you're confused about what I'm saying, please raise your hand. But basically, I'm trying to find the area of ABCD. I want to know what tool do I need to use and what information am I still missing to use that tool. I'll give a little bit of time so everyone can have a look, or maybe put a comment in the chat there. So I see lots of people are saying the area rule, and I think, guys, you are absolutely on it. Then the question then becomes, what information do we need to use the area rule? And we need two sides and an included angle. So if I look at my very first, let me get rid of some of the writing here. If I look at this first triangle, I have two sides, but I don't have the angle in between them. And in order to use the area rule, I need two sides and the included angle. So I want to know in the chat, what is angle D going to be? So the first thing is we're going to use the area rule. We're going to try and find the area of the one triangle and the next one. But I think someone has correctly the included angle. What are we going to get for that? Kuchle, yeah. Lebo, could you unmute Kuchle, if that's possible? I'm just having a little bit of
So
brain.
angle D is going to be 40 degrees.
How did you know that? You're right.
Interior angles of a triangle. So 180 minus 80 plus 60.
Yeah, that's it. So 180 minus 80 minus 60. So D is going to be 40 degrees. So now, once we've got that, we can find the area of this triangle. So I'm going to give it a little bit of time for that. But now, what about the other one? Oh, I see, guys, because we've got 74 already, and we've got 52, and we've got the angle between them. Okay, so we've got all the information we need. So now what I want to see, I want everyone working out the area of the one triangle. Then I want to find the area of the other triangle. Let's call it triangle 1 and triangle 2. And then I want you to add them together and see what answer you get for the area of that whole shape. Okay, so you're going to do that for me. And I'm going to give you some time to do that. I'm just going to put like a little spaces where I think some working out needs to be done. And then I'll take a question. Anika, yes. Oh, guys, if you have a, so please repeat, sir, we get areas for both triangles. Yes. So what we want to do is we want to find the area of this whole big thing. But we only have a rule from this section for finding the area of triangles. And so what we do is we find an area for each of these two, and I've just called them triangle 1 and triangle 2. Now at the top here, we've got this thing called the area rule. Right, so here it is. And what it says is basically I can find the area of a triangle if I have a half times the length of one side times the length of another times the sine of the angle between them. And so that's what you're doing. So for the one down here at the bottom, you've got 52 would be the one amount. And then the other amount, I'm just going to zoom in because I'm running out of space. So 52. And then this one is 59.13, which you worked out. And what's the angle between those two? It's just going to be the sine of 40. So that would be the area of the one triangle. Then I want you to think, what's the area of the other one? And then what do you get if you add them together? So that's the goal so far. And again, for students who are new to this, remember, we've done 7 lessons on this. And so if you just watch 15 minutes of one video around a skill you battle with, a lot of this will be easier. And so while students are working, if anybody wants to raise their hand to ask a question, now is a great time because we can hopefully reinforce some of the ideas I'm talking about. So what is this? This is going to be 74, and this is going to be 52, and this is going to be 36. So what is my final, who would like, is anybody willing to share their answer in the chat? Amukalani, there we go. Amukalani, do you have a question or do you want to make or answer?
So I have a question.
Okay, go ahead.
So for triangle DBC, the first triangle, would it
DBC, yeah.
would it make sense for you? Would it make sense for you to find the side of BC and then work the triangle instead of finding the angle 40 degrees? Could you also do it like that?
You could do it like that. You could, yes. You'll get the
But
same answer.
Oh, okay.
As long as you find BC in a logical way. Although, how would you find BC? Because you need angle D. So in order to find using a sine rule, you need angle D anyway. So it's not wrong, but you wouldn't have enough information. Okay.
Okay, thank you, sir.
Pleasure. Okay, so I see a couple of answers coming in. The units here are going to be meters squared. And so let's see what we get for our final answer here. Let's see if I can magically bring up the block without blowing everything to smithereens, because I have a rather large amount of stuff on the screen right now. You become quite skilled with your, there we go. Look at me, Lebo. I'm becoming a ninja of all things live. On the okay, so we should be getting 2119.11 meters squared. And so I know for students who are, if this is your first lesson, this will look a bit strange, but basically what happened was we found sides, we found angles, and then ultimately we found the area in the end. And so I'm just going to wait a moment more to see if there are any more questions. Otherwise, in the chat, give me a sense. If you're feeling okay so far, give a thumbs up. If you're feeling very lost, give a thumbs down. Just so we get a sense of how the group is doing. And then also take a screenshot if you are running out of time, because I'm going to move on to another question in a moment. Okay. Awesome. Okay, so the screenshot countdown is about to begin. 3, 2, 1, and let's get going. Now, this is a little bit more, has a little bit more going on. And so I want us to have a bit of a discussion before we really get into the heart of it. So if we look at this question, it tells us a little story at the top. And let's read that story together. So it says, the diagram below represent Mr. Nu's vegetable garden. And there's some information about angles, but those angles are already labeled on the drawing. And so basically this is an enclosure for it. Could we hit mute all there, Level? Just to hit mute all? I think there's a bit of a, yeah. Now, what we need to do, the question is asking, calculate the length of the fence that Mr. Nu can use to fence his garden. Now, I want to know in the chat, what do you think we need to do to answer this question? I think to fence his garden, it sounds like we need to go all the way around the outside of here. So I want to ask in the chat, or for someone to raise their hand, what do you think we actually need to do if we translate it into maths? What do we need to find? Or I'd love for someone to give me a strategy or an idea of how they would approach the problem. Okay, Rafiwe, yeah. Hi, Rafiwe. How would you approach the problem? What do you think is a good way? Yeah.
I think we need to find angle S, and then we can start approaching the problem.
Okay, so you think finding angle S. What would you get for angle S while I've got you on?
Let me see, 20 minus 100, 60.
Yeah. So you're right, that would be 60, and I think that is useful to bear in mind. However, if you think about the perimeter, what other information do we know we still need to find in order to answer the problem?
I think we have to find all sides of the triangle.
Yeah, exactly. So we still need to find this thing called MS, and we also need to find this thing called KS, and then add them together. Awesome. Thank you, Rafiwe. I'm going to some other comments, but you're a superstar.
Thank you.
So Rafiwe has been very helpful, but now I want to know, in order to find, let's try and find MS. What tool would we use to find MS? Okay, so Clanati has said the sine rule, and I think I agree. Tando has said the sine rule. Yes. Okay, so I want everyone. Now we've said S is 60 already, and that's because of sum of angles in a triangle. I want everyone to try and find me MS, and then I also, after we found MS, I want us to talk about how we could find something else. But let's try and do that first. So over to you guys. Find me MS. So following the rule from before, MS is over here, and it will be over the sine of 20 is equal to, and then we are going to have, oh, I see why we had to work out S, because the 30, because we know that other side was 60, because we know this is 60. Okay, so what is MS going to be? Notice how when I'm using the sine rule, I always write my sides at the top if I'm solving for sides. Sine of 60. Okay, I see in the chat, a lot of people, and I agree, we're getting 11.85 units. And so we're going to say this is 11.85. Okay, so we're almost there. So now we need to find, after we found that, we still need to find KS. And here we have a choice. For those who would like to continue using the sine rule, we could use the sine rule, I think. Or we could use the cos rule because we have two sides and the included angle. I think most of you would probably use the sine rule because it's probably a little bit quicker, but yeah. So what do you get? My next goal is I want you to find KS for me. And then let's go from, I'm lost. Where did you get 30 from? Okay, so if you look at this 30 down here, I wrote 30 and the angle opposite that is 60. So that's like a pair, those two together. And then MS 11.8, MS should be, so MS, we didn't know that when we started, over the sine of 20, which is opposite, yes, equals 30 divided by the sine of 60. Yeah. Now, when we want to find KS, if you were using the sine rule, would be sine of 100. So KS over the sine of 100, because it's opposite that. And then what I'm going to do is I'm going to say 30 over the sine of 60. And I'm going to try and find what KS is. And there was other ways to do that, but let's just see if you can get KS. And then once we have KS, we can potentially then use all these things together to answer the original question. So let's look at that. So okay. So what are we getting there? Okay, so I think we're almost at. So let's have a look. What is the final answer then for the garden? So I see lots of people are getting 34.11. And so to answer the final, and I agree, so KS is 34.11. And so the final thing then is, what is the perimeter of this guy's garden? How would we answer the question? Well, perimeter, yeah, we're going to add them all together. So we know we have the 30. We know we got 11.85. And you guys just worked out that this was 34.11. So what is my final answer going to be? Lee, what have you got? I'll unmute you.
Hey, sir.
Hi.
I have a question for 2.2.2. No, yeah, no, not 2.2, 2.2.1 actually, where we had to find the side KS.
Yes.
Right. I didn't use I did not use KM. I used the side SM, and then I'm getting an answer of 34.12 instead of 34.11.
Okay, so that's a minor amount of rounding. And so that, in terms of the degrees of accuracy of the problem, I don't see a huge issue with that. So there's also a small amount of rounding in terms of that. I don't think you should round off to, depending on what the question says. This question hasn't specified its rounding bound, so I wouldn't stress too much about that.
Okay, so thank you. I just wanted some clarification on that.
Yeah. Okay, so we should be getting, guys, we should be getting 75.96. If you want to see the whole process with perfect working out, that's how it would look. But essentially you get 75.96. And yeah, I think we're definitely getting to harder questions now. And so let's do one more question before we take a break. Can you work out for me how big the garden is? So you've told me now how much it would take to fence around the garden. The last question we had before our break is I want to know how big an area is this particular garden? And then I'm going to take a question from Rafiwe while we work on that. Yes.
Hi, sir. I wanted to ask is it necessary to write reasons while you're working out?
Okay, so the reason that you have to show reasons, you know, that 60 degree that you worked out at the very beginning?
Yeah.
Because that was, you used the fact that a triangle adds up to 180, you had to show a reason there. But you don't have to show a reason if you use the sine rule or the cos rule.
Okay, thank you.
So guys, in this question, if you round off to 1 or 2 decimal places, there can be a slight difference. I wouldn't stress about that at this stage. You try and keep, depending on the question, if they say 1 decimal place or 2, you follow those rules. But if you got 0.97 instead of 0.96 at this stage, I wouldn't have a heart attack. Okay, so let's try and do how big is his garden, and then we're going to take a little break after that to stand up and stretch. So what tool is going to allow us to find how big his garden is? And then from there, we should be away. It feels to me like the area rule could be handy here. And so if we're going to use the area rule, what would the answer be? Yes, not to Corso, yes. And so after a while, you do get these formulas on a formula sheet, but you start to just absorb them. And so we know for the area rule, it's going to look something like that. And the question is, what goes in those missing spots? I could choose any of the sides, but I'm going to choose these ones because it feels like that would be the easiest. But someone might have chosen different ones, and you'll still get the right answer. So 30, then 11.85, and then the sine of 100. And what answer are we going to get then? I'll put it in my calculator, just do it old school here. Times sine of 100. Yeah, so we're going to get 175.05, and the units are going to be, what do they say? It's meters, so it's going to be meters squared. All right, I'm liking what I'm seeing. I feel like there is definitely, we're getting to grips with this. And again, a reminder about the earlier videos, but we need to invest in ourselves, guys. We need to stretch it out. And so I want everyone to stand up, and I'd love for you to turn your cameras on so we can share in your wonderful stretching. And yeah, Lebo, if you could also help me recognize those students who are treating their bodies right. And so just stand up for a moment, guys, and just roll your shoulders and twist and indulge in whatever stretch you feel is most appropriate based on what sort of day you've had. I've had quite a bit of sitting, so I am going to stretch out my calf muscles. Oh, that feels fantastic. I can't tell you how awesome that feels. I feel alive. Yeah. Okay, and Level, are you with us? Maybe you've popped up for a second. Oh, there we go. There we go. I'll unmute you. Cool.
Sorry, Mr. Is my Wi-Fi kicked me out.
Okay, no, that's fine. I see some very good stretching going on. Lesejo, I see that commitment you have there. I love it. I love it. And Fano and William and Naye. Oh, you make me feel better just looking at you guys. Okay. So let's have a quick little brain break and then we'll get back to the maths. So here is my challenge. We have a few monkeys. We have a few giraffes. Can you tell me how much a giraffe is worth? Over to you guys. There we go. You like the giraffe, Montecorso. You like it. I also like giraffes. Oh my goodness. I'll tell you guys, once upon a time, I saw lots of giraffes. I was in Tanzania and it was the most magical thing. Like 6 or 7 giraffes just chilling in a field. Like,
Oh, wow. That sounds nice.
I'll bring you the picture. I'll bring the picture on Monday. It
cool.
was
Yes.
incredible. There's a good story to go with it. I'll tell the story. But yeah, giraffes are beautiful. Okay, Anika. Hi, Anika. What's your question? So monkey is 4. I agree. So then what is a giraffe going to be equal to? Aha. Anika, can you,
She wasn't unmuting.
Okay. So you're quite correct. A giraffe, a monkey is 4. A giraffe, and I suppose we can use equations here, or you can kind of guess it. The only number that will work, Vuyani's got it, 13 plus 3 is 16. 16 divided by 2 is 8, and 4 times 2 is 8. So the giraffe must be 13. Yeah. So in this world, a giraffe is worth 13. Okay. So that was awesome. And well done to everyone who gave that a go. We like to do a little bit of fun stuff in between just to kind of give our brains a break. Okay, so let's go back to the last part of the lesson. Let's do this question. Let me just expand the size of it. So it's a bit big. Okay, so what I want you to do, last lap for the day. Yep. I want you to try and find me this distance over here called xz, or this side over here called xz. And then after you found xz, I want you to try and find xy, which is down here. And if you have an idea of what tools you would use to do it, put them in the chat, and then give us a hint for those who are new to this. So you're gonna first try and find xz. What tool would you use? And then how would you find xy? Okay. So iPhone, I think you're onto something. And I think you are correct because I see two angles on a side. I see xz is opposite the 30, and then yeah, it seems pretty clear it's the sine rule. Yeah. So how would we find me what xz is? All right. So the good news about these rules is after a while they start to feel quite predictable. Like you can always, so xz over the sine of 30 will be equal to 3 over 120. So what is xz going to be? And we are getting oh wait, I left something out here, guys. You see my silly mistake. My calculator was doing something weird. So the sine of 120, and so then xz should be 1.73. Okay. Now, if I know that that's 1.73, how am I going to find xy? Because I'm a bit stuck. I don't have any angles. And I don't have, I'm kind of like xy is all the way at the bottom here. And I need a way to connect. So I see Kumotsile said the cos rule, and I agree, we have two sides, we have this and this, but for the cos rule, we need something else. What else do we need for the cos rule? Okay, Vuyani, what do you think we need? I'll come to you.
Hello, sir.
Hey, what do we need still?
In the angle XZY, we have two angles. So we need the third one. We'll get the third one.
Yeah, we do. Oh, I see.
Yes, 180 minus 120 minus 30. Yes, yes. And
okay,
when we get one, we'll get the angle Z.
So you're saying, let's call it ZXW. What do you work it out to be? It's 30. Yeah. And then YZX is going to be 30 because there's parallel line there.
Yes, alternating angles.
Oh, fantastic. And let's be very good. We'll say ZY. Thank you, Vuyani. That was spot on. That was super helpful. Okay. So Vuyani has helped us realize that that's the 30. And then in the, if we think about using the cos rule, we can use the cos rule to help us find XY. Very clever indeed. Okay, the included angle. Kuchle, I see you have a question.
Never mind, sir. I got it. Thank you.
You got it. Okay. You see, as a group, like we can always, okay, we're not done yet. There was one question. Do you need to write the reasons? So guys, yes, generally alternate angles. And then we do need to give reasons. I should have actually given a reason here. Sum of angles in a triangle. And that's how we worked out that this one over here was 30. So whenever we make a deduction, we do have to give a reason. Yep. Now we need to think about the cos rule. But the cos rule, remember, it looks a little bit like Pythagoras. So we're going to start by writing x, y. Let's write it a bit more like this. So xy squared. And that's the side that we're trying to find. Now what goes? There's something that goes like over here. And then something over here. And then there's like, I'll say two brackets like this. And then there's a cos. There's that. So that's the rough format that I'm going for. Now, the biggest thing that students take a while to recognize is like which sides go with which things. And what I want to suggest is that this one is all by itself. The other two sides are the ones that are invited to the party. So what are the other two sides? The one is 1.5 and the other one is 1.73. So 1.5 squared over here and 1.73 squared would be there. And then there's going to be a 1.5 that goes here and a 1.73 that goes there. And then we look for the cos of the angle between those two sides, which is going to be 30. Now remember, it's still xy squared. So in order to get our final answer, we're still going to have to square root something. But let's take our time here and realize how, when we apply the cos rule and we're trying to find sides, it always looks a little bit like Pythagoras, and then it has this bonus part at the end, which is added on. So I see lots of answers coming through. Let me just work it out myself. So So 1.5 squared 2 times cos of 30. So this isn't the final answer, but xy squared would be 0.7482 and I'm going to use the answer key now. So I've hit equals, and this number is in my calculator's memory, and I'm going to go square root answer key, and we get 0.86 is what I'm getting. 0.87, sorry, if I round off. So so xy should be 0.87, and that will be meters. Let me just bring this out. So 0.87 meters. So a little trick I use, everyone, is I typed out that whole long 1.5 squared plus 1.73 squared minus and so on. I got a value, and it had 0.74, and it had all these decimals, and that's fine. That's why I put the 3 dots. But then that value is stored in my answer key variable on my calculator. So then I went square root, I hit the answer key button, and it just square rooted that long number for me. And then the answer is going to be 0.87 meters. Okay, so guys, what that is a little bit of a taste of how we can combine questions to have to use the different rules. Now, in today's quiz, we are giving you a combination of questions from throughout the module. So a little bit of the sine rule, a little bit of the cos rule, a little bit of the area rule. And so before we put the link in the chat, are there any final questions before we end the lesson? We've got a moment or two ahead of us. So I'm happy to take a question if someone is a little bit unsure of something. And Lebo, if you could please put the link to the quiz so that those students who are comfortable, ready to take the quiz, they can go off and do that now. Okay, yes, William, I see. Hi, William.
Hi, sir. The question I have is, when we're looking for angle X, because we want to use the cos rule to find line XY, is it possible that we find angle X using the angles of a triangle, and then we say 90 degrees minus 30 degrees to find the bottom angle and the top angle?
Okay, so you're saying, is this the one over here you want to find, that one down there?
Yes, sir.
Okay, so in this question, it does look like it's 90. The only problem is it doesn't say it's 90. And so you're making an assumption. So yes, I agree it looks like that, but you can't say for sure. So my advice would say you would avoid that because it hasn't been formally stated. I think if it's, don't 120. Yeah, I would say you would generally avoid that because it hasn't been formally, it should have a little right angle symbol. Yeah.
So, okay, thank you, sir.
Cool. I think students, those who are ready to go off now and have finished the lesson, you can go off and take the quiz. You don't need to come back to class after you go off. And I hope that you have a fantastic, quiz experience. Okay. Can I take your question? What's your question?
Hello, sir. Can you hear me?
Loud and clear.
I would like to ask about the part where you were doing xz is equals to 3 all over sine 20 and sine 30. Our Wi-Fi had kicked us out. I wasn't part of the lesson then. Okay,
so basically xz, let's just make sure you can see these parts. So when we started, the very first question was to find xz. So xz is this bit here. And you'll notice that opposite xz is this 30. And so that's why when we write the sine rule, we write down the thing we want to find, and then it's divided by the sine of the angle opposite that. And then the other part is we start with the side on top again. So here's the 3. And so what's opposite the 3? It's the 120. So that's where we got that from. Does that help?
Yes, sir.
Awesome. All right, everyone. So we're going to finish the class there. And then for those students who it was your first lesson, I cannot emphasize this enough. We've done some really good practice, and it may just be that you need 15 minutes of an earlier video to help you. But remember that this was the combination of a whole bunch of lessons. And so I really don't want you to be too hard on yourself if you feel a bit overwhelmed today. Okay, it was great teaching you. I'm going to wish you well